Do I need to do something like say that um C is 4x and A is x or something like that? Or
Yep. Let's see. So let's say the tension in C is T, and so this is 4T, something like that. So what else can we add to the...
so mass is 60. Does that mean that the kilo is like pulling downwards?
Yeah, where would that go?
A just in like the middle.
Yeah, so that's... And it's kilos, so it's 60G.
Okay.
40 kilos attached at B.
Just going to put 40G.
Yeah, and we need the tension in the wire at C.
Was this where I had to do like? Is this the thing we did last time?
Mm-hmm.
Is this like having to do 60 times 40 or something equals to 2?
There's something simpler.
Okay.
What would the total... Oh, there's something very simple about this, actually. What is the total weight?
100.
And what is the total tension?
Was it 0 or something like that?
No? Total tension in the strings.
Is it 40 and 2?
What do you know?
Oh, 5, 5, 2.
And what do you
So,
know about?
does that mean that 100G is equals to 5, 2?
Yeah.
And so T is 20 grams.
Not grams, G.
G, sorry.
20 times 9.8. Part B, the distance B to C.
So B to C. So we know that 5T is equals to, or so 5M makes up A to B.
It doesn't matter.
Okay.
So this here is 20G. This here must be 80G. So take moments about B.
So it's ready to do like 60 times 80 or something.
Something like that. Let's see. Distance from B to C. Sorry, distance from B to the 60G force.
2.5 meters.
So that one's 2.5 times
60.
60G. What other forces do we have? What other distance?
A to a moment of A.
And so what's so do something similar for the tension at A.
Oh, do I need to do for B? Do I need to do like times 20 or something?
Yeah. So what times 20, or how would you express it?
Is it 2.5 times 60 times 20 or?
No, you've got three different forces. So same thing, the force for A, distance times force.
So is that 80 times 5?
Yeah. So that's 5 times 80g. And is that positive, negative?
So I think it's going clockwise, so negative.
Yep. And one more.
Okay. And so am I now doing times 40 or something? Oh, am I doing like, sorry, no. Is it 2.5?
We did that one.
Oh, sorry.
So we did 2.5 times 60g. We did 5 times 80g. And distance times force for the last one.
So I need to find out the length of BC, which is x.
Yeah.
So will it just be x times 60?
The force x meters away from B isn't 60.
40, sorry. Oh no.
No. What's the force x meters away from B?
20.
Yeah. Plus or minus?
Is it going anti-clockwise, so plus?
So B is the moment that it's spinning around.
Sorry, so clockwise, so minus.
Yeah. So those are our three forces. It's held in equilibrium.
Do I need to add in the minus and the 5 and or something, or?
No, we already found those. This was like 4 times this one. So 80 is 4 times 20. If they're in equilibrium, they add up to 0.
Yeah, okay.
And they all have a g, so we can divide everything by g.
And so does that mean that it would just be x is equals to 20?
No. 2.5 times 60 minus 5 times 80 minus x times 20 equals 0.
Oh, if I can put that into my calculator.
Yep. Oh, did you have it written down?
No.
Ah, okay. It was 0.625. You'll be fine putting it. You know, it's not difficult, the rest of it. Yeah. Let's see. We'll try something different. We'll just move on, see how we do. Because it still involves it. Like, now you just have to find... So that was a uniform rod. Uniform, the center of mass is the middle. Now we'll have a thing where center of mass is in a different place. But other than that, it's very similar. So we're not just doing the same thing over and over. Okay, let's give this one a go. Example 9.
So okay, so are we gonna have to start doing labeling again?
Yeah.
So AB is apparently 25 kilos. So I'm assuming that's in the middle.
AB. No, it's non-uniform plank. And so
Sammy doesn't.
hang on, it tells us the center of mass is at C. And so, what's the downward force at sea?
Say 25.
25G.
Yeah.
Which is like 25 times roughly 10. So you can't just say 25. Okay, what else?
So do I need to label Sam for being 35 kilos?
Yeah. So Sam, what's the downward force there?
35G.
Okay. Tamsin
Also has 25G.
And there's one more force, believe it or not. Any idea what it is? It's going to be a reaction off of that one. The reaction at M. Any idea what that's going to be?
Will that be like all the weights added together?
Yep.
So will that be 85G?
Well done. Okay, 85G. So we know Tamsin is at A. The center is at C. The midpoint reaction is at M. We need to find where Sam should sit so that the plank stays horizontal. Any idea how we do this?
We take moments.
Yep.
So are we first going to do that moment of A, for example?
So I'll try to give you something that's a bit more intuitive. Let's take moments about M, the center. Let's say to the left, what are the forces and distances going to the left?
The force and distances going to the left, is that like 1.8 meters and stuff?
Yeah. So what's force times distance for the two forces to the left?
Will it be 25 times 1.8?
Distance from M, not distance from A.
Also 2 times 25?
So 2 times 25G. Go on.
And then do I need to find out if it's clockwise or anti-clockwise?
It's anti-clockwise. They'll both be anti-clockwise.
And so will it then be like +4?
How do you get 4?
Oh, sorry, I was just using the distance.
So you got this Tamsin force. Now do the force at C.
So will that be just the same?
Distance?
Or 1.8?
Distance from M to C?
Oh, 0.2?
Yeah. 0.2 times?
85?
No. Force times distance. Distance times force. So it was 0.2 away from C. Force at C?
25.
So 0.2 times 25G. So before we do anything else, we looked at the two. We took like the midpoint. Take a moment about the midpoint. For this beam to be horizontal, what do you know about the forces on the left and the right of M?
They're unbalanced.
If we want it to be horizontal, like Sam can move.
So, do we need to say if they're going to move? Should they move backwards or forwards or something? Or?
Well, we don't know where Sam is sitting, but basically, they have to be equal. Like these two on the left have to be equal to this one on the right.
Okay.
So, like I picked the midpoint. Okay, and so how about Sam?
So is Sam sitting at 10G too heavy?
Say it again, sorry.
Is Sam sitting at 10G too heavy?
Are you saying 10G too heavy?
Yeah.
That's his weight. That's not a distance. Let's say the distance is x.
So, okay. Do I now need to take moments for that, for where Sam is or something, or?
Yeah.
And so will that be 2 times 35 plus x times 25?
X times 35G. And how did you get the 2? Was that for Tamsin?
I just used the 2 because it was halfway. But that might not be right.
No. So we don't know. So it's just x. So if we're taking moments about M, you want the distance from M to Tamsin times by his force. So 2 times 25G. Distance from M to C times its force, 0.2 times 25G. Distance from M to Sam and his force, x times 35G. We know that these two on the left have to be equal to this one on the right if it's to be balanced. And so 2 times 25G plus 0.2 times 25G is equal to x times 35G. And so we have to solve for x to see where Sam should sit. So try solving for x there.
Okay. I got 11 over 7.
So x equals 11 over 7 meters. Yeah, I think that's it. What is it? Roughly 3. Oh, they're saying from A. Yeah. So if you add 2 to that, do you get, is that roughly 1.57?
Yeah, it's 1.57. Yeah.
Yeah, that's it. Because they didn't actually say like from where. They just said where must he sit. So let's say from M, like to the right of M. Yeah, and so if he sits like somewhere, 1.3, odd meters, then it won't be too far and it won't be too close. And so it will balance out with the left side. Okay, so same exact question. Let's now take moments about A. So I just took the kind of the midpoint because it's kind of a bit intuitive that like the left side has to equal the right side. This time we'll just say everything adds up to 0. And so take moments about A. What do you get?
Okay, so will that be like 2 times 85 plus will it then be plus 0.2?
This time distance from A.
Oh, so will it just be 2 again, or?
Well, you did the 2 force. 85G is 2 away from Thompson.
Is it 1.8?
Yeah, 1.8 times
25.
And that one is negative.
So I just do 0.
What from A, is it 0 times 25G?
Yeah.
Yeah, so it's in the same way in the previous one we didn't include the 85G, so it would be like 0 times 85G. Yeah, that's what's happening there. 0 times 25G, so we don't need to worry about that. And so how about Sam?
So am I now doing moments about Sam?
No. Moments about A. So you did the C force, you did the M force, now the Sam force.
And so am I now going to do X times 85G?
No. So what is the distance from Tamsin to Sam?
Oh, sorry. 2 plus X.
Yeah. And the force?
25.
What force is it? That is 2 plus X away from Tamsin.
35.
Yeah, 35G. And what do these forces add up to? If we wanted to stay in equilibrium.
0.
Yeah. So the whole thing is equal to 0. And if you put it in the calculator, this time you should get same thing. X equals 11 over 7. So 1.5. So C distance times C force. M distance times M force. Sam distance times Sam force. And it's all from A, because we're taking moments about A. And you get the same answer. If you took moments about Sam, you'd get different working out, but the same answer. It would be X times 85G, whatever, 0.2 plus X times 25G, and then, well, that'd be a tricky one. All right, so any questions about how that works?
No.
Okay. Let's see. I just want to see this one. I'll go with the diagram that they have. Okay, we're trying to solve for X. Let's try this. And hang on, is this in equilibrium or something? Non-uniform rod. Yeah, it's horizontal. And so that means it's in equilibrium.
So Are we doing the same thing basically?
Yeah, there's a little more to it. Can you solve for R?
Is this where I do like 3r plus 4r? No, 3r plus r equals to 4r.
Yeah. What else is it equal to?
The rm or something.
Total reaction is equal to total downward force.
So it's equal to 20.
Yep.
So r equals to 5.
So R is 5. Okay, so that's 5, that's 15. Okay, we have to solve for X. How do we do this?
So should I sub in the value r first for all of the forces?
So I subbed it in. It's
Alright.
5 and 15.
And so, sorry, what did you say we need to do next?
I didn't. You tell me.
I'm assuming it'll take moments.
So the reason why, if you take moments about any point, I'll just pick A. Moments about A will equal 0. Where is it? It is resting and it's horizontal. And so that means it's in equilibrium. That means its total rotational force is 0. So you have some that are pushing it clockwise, some that are pushing it anti-clockwise, but overall it's 0. And so if you can write down all the forces, you can solve. So yeah, let's try taking moments about A.
Okay. So will that involve doing... Oh, do I need A's weight first? Force, sorry.
A is it?
Yeah.
There's nothing at A. We're just, when we take moments about A, we're imagining that A is like a hinge. And so the whole thing can like move like that about A. So we're taking the rotational force about A, something like that. So just distance times force.
So would it be 1 times 15?
Yeah, another.
1 times 1.5?
Distance times force.
1 times 5?
Distance from A to that force.
Which will be 2.5.
Yeah, and so 2.5
times 5.
Yeah, one more force.
Is it now going to be x times 20?
Yeah. What do we know about those 3 forces?
They equals to 0.
Yeah, because it's in equilibrium. And now let's just figure out which are positive, which are negative.
And so will the first one be positive, sorry?
Yep.
And then will the second one be negative as well?
The first one was positive. So the second one, is it positive as well or negative?
Positive, sorry, positive.
Yeah.
And for the next one, it's clockwise, so negative.
Yep. Okay, solve.
Okay. Yeah, I got 11/8.
11/8. What's that as a decimal?
1.375.
Okay, so this 20 force has to be 1.375 meters away from A. Oh, I don't have the answer. But yeah, that's it. I suppose I could. Oh, I do have the answer. This is the answer thing. 1 sec. So 1.3. Testing. Hang on. This is laptop. So yeah, they rounded it to 1.38. There we go.
Okay.
And so for all of these, if you take moments about any point, it'll be equal to 0 because it's in equilibrium. And so we took moment to A, distance to C times force times C force, distance to D times D force, distance to 20 times 20 force. And then you go from there. Figure out what's positive, what's negative, all that stuff. Let me just see. Suppose I could. Oh, I just want to try. Okay, let's give this a go.
Okay.
How do we do this?
So labeling the points, I think, for a start.
Mm-hmm.
So when it has mass 24 kg, so you need to put as 24G in the middle.
Yeah, that's if it's uniform. Is it uniform?
So shall I then put 15 kilos for C then?
Let's do that first. So what would be the downward force at C?
15.
It's kilos, not newtons.
15G, yeah.
Yeah, 15G. So that one's 15G. The other one, the 24 kilos, it's in part B. I'm just going to put it approximately there. I think it's closer to A than B. Okay. Any other forces?
Like an upwards force.
Yep. At A and B. Those two tensions. So you have tension in A, tension in B.
Do I need to add the two 15 and 25 together?
Mm-hmm.
and that'll give me 40.
Mm-hmm.
Um, I'm not sure.
It says something about A and B. Oh, it says that's in part B. Okay. Hang on. A plank has mass of 24. I wrote 25. See where AC load its plank. Oh, the plank at first is modeled as a uniform rod. Find the tension in the rope attached at B. Okay. You could take moments about A.
Okay. So am I just do like TA times 1.4 or something?
TA isn't 1.4 meters away from A.
Oh, so I should leave that as 0.
Yeah.
Should I go on to the next one?
Yeah.
So is that 1.4 times 15?
Yeah.
And do I then do 2.4 times 24, 25, sorry.
4 times 24G.
And is that it for the moment?
There's one more force.
Is there an upwards one?
Yeah.
So is that going to be the 40G one?
How do you get 40G?
From 15 plus 25?
No. Tension at B is like X. That's what we're trying to find.
So am I just going to do plus X times 48? 4.8, sorry.
Yeah. This isn't an equation though.
Equals 0. I need to put in the symbols in between as well.
Yeah.
Okay, so for 1.4 times 15, so had we said that when you're doing that kind of stuff, does it leave from A, like the arrow?
Does it lead from A?
Like leave from A. So does is it meant to be going from C every time, or is it to A?
Goes from A every time. Distance from A to times force.
So will the first one be clockwise
Yeah.
and therefore negative?
Yeah.
And will the second one be clockwise, so therefore negative as well?
Yeah.
And will the third one be will it now be negative again?
This one is going anti-clockwise.
So positive, okay.
Yeah.
And then just calculator.
Yeah.
I got 53/4.
And there's a decimal.
Yeah, I got 13.3.
Equals X. So that's going to be newtons. 13.3. Let's see. They took moments. Taking moments of A. They did B times 4.8. Oh, we can't cancel the G's. Wait. 4.8 times. What answer did you get, sorry?
13.25.
Multiply it by 9.8.
129.85.
Something's wrong. Let's see. 1.4 times 15G. That doesn't make any sense. Now they're taking moments of A, so the tension in B times 4.8. Tension in B is X times 4.8. But it's the only one that doesn't have G. 1.4 times 15G. 2.4 times 24G. Yeah. But they don't. So tension in B times 4.8. So just remove the G, the times 9.8 from the 4.8. So have the other two have times 9.8, I believe.
So, do you want me to just times 9.8 again?
No. Let me see. So if we just put the whole thing in, except the other two have 9.8. Let's see. 4. Okay. 52.3. If I multiply this by 9.8.
52.475. Yeah.
What am I doing wrong here? Is that what? They rounded it. They just rounded it heavily to 2 sig fig. No. Sorry. So I was right the first time. But I lost the thing. They just rounded it to 2 sig fig. It was like 156 or something, was it?
129.
No. Okay. So, the last force, tension in B. There's no G. It's just that X times 4.8. Okay, let's try B.
Okay, so That's the thing for me. So does that mean just from the midpoint?
So it's a non-uniform rod this time. With the new model, the tension in the rope at A is 25 greater than B. So I'm going to say, oops. Let's say they moved it. I'm just going to say they moved it to there. If the tension is greater at A, then maybe it's closer to A. So it was 15G, 24G. So that's 24G. That's 15G. And how can we express the tension in A, tension in B?
Is that by adding up the forces together?
That would work actually, I think. Yep. So how would you do part B?
Am I doing 20? Am I doing? Do I need to add up TA and TB as well?
Well, yeah, but try to express them using 25 newtons greater. How can you use that information?
So I change TA to TB plus 25.
I think it would be TB minus 25, would it? If A is greater, then you'd have to subtract 25.
Yeah, sorry. So TB minus 25.
Yeah.
And so am I doing TB minus 25 plus 24 plus 15 plus TB?
Equals?
Oh, sorry. Equals to. So here it's non-uniform. Oh, is that where it's equals to like the distance?
Oh, you're a very confused boy, Andrey. Total. So this will be a different thing. Total upward force equals total downward force if it's in equilibrium.
Sorry, did you say total upward force equals total downward force?
Yep. If it's in equilibrium.
Oh, so is it meant to be? Oh, but did non-uniform mean that it's not in equilibrium?
Non-uniform means the center of mass isn't in the middle. That the 24G isn't in the very middle anymore. It's centered somewhere else.
So back when we were writing out those pluses, did we have to do it equals to? Are we doing TB minus 25 plus TB equals to 24 plus 15? Or
yeah.
Okay.
Yeah, maybe I'll just call it T for tension. So T minus 25 plus T equals 24G plus 15G.
And now I need to just solve that.
Yep.
I've got 32.
And did you include the G?
No.
So 24 times 9.8 plus 15 times 9.8, and the other one doesn't have a times 9.8. It's just 25.
I just need to add in 9.8.
Yeah, so 24 times 9.8 plus 15 times 9.8 plus 25. That's 2T.
I've got 203.6.
203.6. Let's see. So what did you put into the calculator?
I did like x minus 25 plus x equals to 24 brackets 9.8, and then plus 15 brackets 9.8, and then
That should work. And so I'll just solve the thing. So 24 times 9 point.
Oh, and I just added to the 25 and I got 216.1. I'm not sure if that makes
You already had the 25.
Yeah, okay.
Plus 15 times 9.8 plus 25, whole thing divided by 2. 2. Is that what you got? 203.6?
Yeah.
Okay, what are we missing here? Oh, they did plus 25. Why is it plus? Detention. Oh, this will still work. What we have is still fine. So let's just go with what we have. 203.6. They worked out the. If you subtract 25 from 203.6, you get their answer. We did tension in B. They did tension in A, and they just added 25 to get B. So that's 203.6. And then that answer, subtract 25, gives you 178.6. Yeah. So they did A, we did B. 178.6. Okay, we have to find the distance x. How would you do that?
Am I now going to do half of 1.4?
Why is it half?
I assumed that 24G was in the middle of 1.4 meters.
No, it's just somewhere. It might even be to the right of C.
Yeah. Will it be like 4.8 minus 1.4?
Just pick a point. Take moments about A, let's say.
Yeah. So am I doing 178.6 times x?
What is the distance, the horizontal distance from A to the 178.6 force?
From A to 170.
Yep. So that force disappears if you're taking moments about A.
And so am I now going to do x times 24?
Yeah, don't forget G.
24G, sorry. And 1.4 times 15G.
Yep.
And 4.8 times 203.6.
Yep.
And do I now need to work out if it's plus or minus?
Yep.
So first one, I think that's minus.
Yep.
Second one, I think that's minus.
Yep.
And third one, maybe plus.
Yep.
Yeah. And then now
and what do you do? We're trying to solve for x.
Yeah. Am I trying to say equals to 0 or something?
It's equal to 0 because it's in equilibrium. and so
Yep.
it's not go overall. So this is turning clockwise with some force. This is turning clockwise with some force. This is turning anti-clockwise with some force, but it's in equilibrium. So the total moment of force is about A are 0. It's not slowly turning clockwise or slowly turning anti-clockwise or something. It's staying still. So those will add up to 0. And calculator.
Yep.
Oops. Did you get an answer?
I got quite a long decimal.
3.28.
I must put in wrong. So
Did you put in 9.8?
Yeah.
Then I don't know. What was your one?
I put in. I got 1,006.68.
Oh, okay. Oh, I don't know why you have such difficulty with this. Okay, this girl is phoning me. I don't know. Just be careful with the calculator. Who knows? Anyway, yeah. How was that for you, Andrey?
Tricky stuff.
Yeah, we'll try next section next time or maybe we'll do stats. Any questions for me in general?
No, I don't think so.
All right. Well done, Andrey. You're doing great. I look forward to talking again next time.
Okay, thank you. See you on Friday.
All right. Take care. Goodbye.